Okay, I'm going to do the this problem from the homework, the last homework I believe, and the rotor problem. And we discussed this in the class, but I'm going to discuss it again. So here we have the rotor, and the rider is pinned to the wall, and Fn is pointed along the x direction. This is our x direction, positive toward the x-axis. You guys remember that? And then I have Fs pointed up. A reason I'm taking it as Fs because there's no motion along y direction. Therefore, the friction is actually static. And then these are the forces that I have. The question 1 asks us to use Newton's laws along y direction. So here we go. Sum of Fy equals to mass times Ay. In this case, Ay equals to 0 because there are no motions, right? No motion along y direction. So just to quickly do the table. At this point, you guys know how to do the table. And we take all the angles with respect to the x-axis measured in counterclockwise direction. Remember, this is y table. Therefore, usually we start with x table, but the problem actually asks us to use the y direction first. Therefore, we are doing it along the y direction. So remember, it is not cosine, we are using sine in this case, right? So Fn sine 0, angle is 0 because it is pointed along the x direction. And then Fs sine 90, it is making 90 degrees with the counterclockwise direction with respect to the positive x. And then Fg is sine 270. So check it out on the calculator. Sine 0 is a 0 and sine 90 is 1, therefore here you have only just 1. And then sine 270 is a negative 1, therefore here you have negative Fg. Fg equals to mg, so you have negative mg here. Now you can take all these things and substitute for sum of Fy because this is our sum of along y direction. Now over here we said that y-axis forces, sum of Fy, the net force along that is 0 because Ay is 0. So sum of Fy from the table, we have a 0 and a Fs and minus mg. So that equals to 0. So you basically get Fs equals to mg. And then the mass of the rider is given to us as 55 kilograms. So you can substitute Fs equals to 55 times 9.8. And that is the answer. This is how you get the answer for static friction force, and that would be 539 newtons. I mean, I'm using 9.8 for gravitational acceleration. And then the second part, assuming the static friction is at its maximum, find the Fn normal force. So again, we discussed that when the static friction is at its maximum, we are using, this is part B, we are using Fs equals to at maximum. Okay, so I'm just going to using the m here to show that it is maximum, and there you have mu s times Fn. So Fs maximum, we already have that as 539, and then mu s, that is the static friction, and it is given to us over here 0.25. that is a coefficient of static friction actually, and you can use it as 0.25 over here and times Fn, and using this you can find Fn, and that equals to 539 divided by 0.25, and use your calculator and find what Fn is, and that is the normal force pointed along the direction toward the center, right? And then if the diameter of the rotor is 10 meters, find the speed of the motor. So remember, what we have here is not the radius, it is the diameter. So we are looking for the speed, and we know already that the net force along the direction of the center, sum of F equals to mass times A, and toward the center this term becomes Fc, and the other side we have m times AC, and AC equals V square divided by R, and this is where we need R. Mass is given to us, R is like, you know, given to us as a radius. I mean, in terms of diameter is 10 meters, so you can find r equals to 10 divided by 2. And on the other hand, you have FC. Now FC is the net force pointed toward the center, right? So we don't have the table for the net force toward the center, so we can actually get the x table here because x is toward the center. And you have Fn cosine 0, and Fs static friction, and along x direction, and that is Fn's cosine 90. I am referring to the same picture that I drew all over there, the force diagram. And then we have Fg along x direction, so that Fg also is cosine, I mean, it doesn't really come either. Cosine 270 is a 0, therefore this term becomes 0. Cosine 90 also is 0, therefore that term also goes to 0, and the only term that remains is Fn. So after we find this Fn, we can take it over here and substitute. So this is the net force toward the center, and the net force toward the center is what you call as the centripetal force. Now Fn already we found earlier to 2156. So you can solve the equation. 2156 equals mass of the rider. Let's go back and find out. It is rider is 55 kilograms, and v square we don't know, and then the radius is 5. So we can do the math here. 5 and 55 cancels out, 11, and then both sides divide both sides by 11, and this is simple algebra. Of course you can do that and take the square root, and there we end up getting v equals to 14 meter per second. All right, so that's the problem. I hope you understood that. If not, you can talk to me during my office hours.